Hello friends, so welcome to lecture series on multivariable calculus. In the last lecture we have seen some properties of partial derivatives. Now we will see chain rule, what chain rule is and how we can apply it. Now suppose w is equals to fxy, function of two variables. Okay. Now first come to function of single variable. Suppose we have z equal to fx, function of single variable, and say x is a function of t, some function of t. Okay. So if we find dz by dt, so it is nothing but df by dx into dx by dt. Okay. This is in single variable function. If we have a function of only one variable x, where x is a function of t, then dz by dt or df by dt is nothing but df by dx into dx by dt. This is a chain rule for single variable function. Now we extend the same rule for several variable functions. Now here instead of one variable we are having two variables. Okay. And say x is a function of t and y is also some function of t, and we are assuming w, x and y all are differentiable functions. Okay. We are assuming that w, x and y all are differentiable functions. So if we want to find out say dw by dt, because when you substitute x as a function of phi t here and y as a function of psi t here, so it will be a function of single variable t. Okay. So instead of partial derivative we will be having complete derivative dw by dt because now w is a function of only one variable t. Okay. So this dw by dt can be written as, now w is a function of x and y, del f by del x into dx by dt, because again x is a function of only one variable t here, plus del f by del y into dy by dt. Because f is a function of x and y both are the functions of t. So by chain rule we are having this expression to calculate dw by dt. Now what is the proof of this chain rule? How we are obtaining this? So proof is quite simple. Suppose t is changing from t naught to t naught plus delta t. Okay. And the corresponding change in x is delta x, y in y it is delta y, and in w it is delta w. This is an increment in x, y and w. Because t is changing from t naught to t naught plus delta t, there is a change in delta t in t, in the variable t. The corresponding change in x, y and w are delta x, delta y and delta w respectively. Okay. Now suppose P is a point x t naught and y t naught. Because x and y both are the functions of t, at t naught we are assuming that this point is P, which is given by x at t naught and y at t naught. Okay. Now since function w is a differentiable function of x and y, so we can always take w as delta w, which is equals to it is del f by del x into delta x plus del f by del y into delta y. Okay. Plus epsilon 1 into delta x plus epsilon 2 into delta y, where epsilon 1 and epsilon 2 both tend to 0 as delta x delta y tend into 0. This is by the definition of differentiability. because we are taking w as a differentiable function of x and y. So by that we can easily write delta w as del f by del x into delta x plus del f by del y into delta y into this plus this, and we are taking this at say point P. So, we are taking this as point P. Okay. Now, you divide the entire expression, this entire expression by delta t. So, what we will obtain? Delta w by delta t is equals to del f by del x of p into delta x by delta t plus del f by del y of p into delta y by delta t plus epsilon 1 into delta x by delta t plus epsilon 2 delta y by delta t. So, we have divided the entire expression by delta t. Okay. So, what we will obtain? We obtain this expression. Now, take delta t tending to 0. Now, take delta t tending to 0 both the sides. So, what we will obtain? Now, dw by dt at t naught will be limit delta t tending to 0 delta w by delta t, which is equals to this is equal to this expression. So, you apply delta t tending to 0 in this expression. So, what we will obtain? It is del f upon del x at p naught or p. Okay. Now, delta x upon delta t when delta t tending to 0 is dx upon dt, and we are taking at a point t naught plus delta f upon delta y at p into, again when delta t tending to 0, delta y upon delta t will tend to dy upon dt at t naught plus when delta t tending to 0, this means epsilon 1 and epsilon 2 will tend to 0, okay, because these are the function of delta x and delta y, and when delta t tend to 0, epsilon 1 and epsilon 2 both will tend to 0. So, plus 0 into dx upon dt at t naught plus 0 into dy by dt at t naught. Okay. So, this implies this is equals to del f by del x at p into dx by dt at t naught plus del f by del y at p into dy by dt. So, we get back to the same expression again, and it is valid for every p and every t naught. So, we get back to this expression. So, this is how we can obtain the proof of the chain rule. Now, we will solve some problems based on this first. Now, the easy way to remember the chain rule is by tree diagram. So, how can we obtain this? What is tree diagram? Now, you see as w is a function of x and y. Okay. So, this w is a function of x and y. Okay. And x and y both are the functions of t. So, x is a function of t and y is also a function of t. Now, it is f and a function of x, it is x. So, it is del f by del x. When you take derivative here, it will be a partial derivative del f by del x, and from here to here it will be dx by dt. Okay. Again here will be del f by del y, and this will be dy by dt. Now, we have to write say dw by dt from here, from this point to this point, dw by dt. So, how can we remember that expression? Now, you simply multiply one branch of this is this into this, the other branch of this will be this into this, and add them. So, simply this will be del f by del x into dx by dt plus del f by del y into dy by dt. So, this is how we can easily remember chain rule. This is called tree diagram. Okay. This we call as tree diagram. So, now let us solve some problems based on this. The first problem is W is equal to, it is x cos y plus e raised to power minus x into sin y. So, here W is a function of x and y, and x is t square plus 1 and y is simply 2t. So, W is a function of x and y both are the functions of t. So, we want to compute say dw by dt. So, how can we compute dw by dt? It is del f by del f or del w, you can say, no problem, del w by del x into dx by dt plus del w by del y into dy by dt. By the chain rule we can say this thing. Now, del w by del x is, you simply differentiate partial respect to x keeping other variables constant. So, it will be cos y minus e raised to power minus x sin y, and dx upon dt from here is 2 into t plus del w by del y. You differentiate partially this expression respect to y keeping all other variables constant. So, how can we differentiate? It is minus x sin y plus e raised to power minus x cos y, and dy by dt is 2. Okay. So, we have to compute this value, this expression at t equal to 0. So, dw by dt at t equal to 0 will be. Now, when t is 0, x is 1, and when t is 0, y is 0. So, at t equal to 0, x is 1 and y is 0. So, you simply substitute x equal to 1 and y equal to 0. So, cos 0 is 1, 1 minus e raised to power minus 1, sin y is sin 0 means 0, and t is 0, that 2 into 0 plus e raised, it is x is 1. So, it is minus 1 into sin y is sin 0 plus e raised to power minus 1 into cos 0 is 1 into 2. Okay. So, this value is equal to, so this is 0, this is 0. So, this is 2 upon e. Okay. So, that is how we can obtain this value. So, now we will try one more problem based on this. Now, W is, it is x cube, x square sorry, plus 2xy square plus y cube, where x is e raised to power t and y is cos t. So, again at t equal to 0, x is 1 and y is also 1. Okay. So, what will be dw by dt? Again by the chain rule, it will be del w by del x into dx by dt plus del w by del y into dy by dt. So, that will be equal to del w by del x, that is 2x plus 2y square into dx by dt is e raised to power t plus del w by del y is 4xy plus 3y square into dy by dt is minus sin t. Now, when t is 0, this is 0. So, this entire expression is 0, and when t is 0, it is 1. So, x is 1, y is 1. So, it is 4. X is 1, y is 1, 2 plus 2 4 into 1 is 4. So, this value is simply. Now, come to functions of 3 variables. Okay. Now, suppose f w is a function of 3 unknowns 3 independent variables x, y, z, and x is a function of t, y is a function of t, and z is a function of t. Again, suppose that f is the differentiable functions of in x, y, and z, and x, y, z are differentiable functions of t. Then if you want to find out dw by dt, so it is nothing but del f by del x, because now function w or f is a function of 3 unknowns x, y, and z, and each is a function of t. So it is del f by del x into dx by dt plus del f by del y into dy by dt plus del f by del z into dz by dt. This is by the chain rule, and the by tree diagram also we can see this thing. Here w is a function of x, y, z, function of x, y, and z, and x, y, z each is a function of t. So x is a function of t, y is a function of t, z is a function of t. Okay. Now from this branch it is del f by del x, and from this branch it is dx by dt, because only one unknown is there. It is del f by del y, and it is dy by dt. It is del f by del z, it is dz by dt. So if you want to compute dw by dt, so it is this into this plus this into this plus this into this, which is this expression. Okay. You take the first branch first, this into this branch, this into this, and second and the last third branch, this into this, and add them. So we will get the chain rule for this function. Okay. Now let us suppose w is a function of n unknowns, and each xi is a function of t. Okay. And suppose you want to compute dw by dt. So again by the chain rule, how can we write this? This will be del f by del x1 into dx1 by dt plus del f by del x2 into dx2 by dt plus and so on, plus del f by del xi del xn into dxn by dt. So that is summation I from 1 to n del f by del xi into dxi by dt. So that is simply dw by dt. So also by the tree diagram also we can say this, it is function of n variables. So it is x1, say it is x2, x3, and so on up to xn. Okay. And each is a function of t. Okay. Now from this branch it is del f by del x1, it is dx1 by dt. From here it is del f by del x2, it is dx2 by dt. It is del f by del x3 into dx3 by dt, and from the last branch it is del f by del xn into dxn by dt. So therefore dw by dt will be this into this plus this into this plus this into this and so on up to this into this. Okay. So that is how we can easily obtain dw by dt applying chain rule for n variables function. Now suppose w is a function of x, y, z, and x is a function of say r and s, y is also some function of r and s. Instead of one variable, now suppose and z is also a function of say phi is also a function of R and S. So, instead of only one variable, now suppose x, y, z all are the function of two independent parameters, two independent variables R and S. Now, when you substitute x as a function of R and S, y as a function of R and S, z is a function of R and S. So, overall this function will be a function of two unknowns, two variables R and S. So, instead of complete derivative, now we will be having partial derivative. So, basically now we will be having either del w by del r, or we will be having del w by del s. So, how can we compute del w by del r or del w by del s? Again we can write chain rule for this function. This is x, y, z, it is x, it is y, it is z, and it is all are functions of r. If you want to compute del w by del r, so write only r in the bottom of the tree, okay. And when we want to compute del w by del s, so write s in the bottom of the tree, x, y, z, it is x, it is y, it is z, and each is a function of s, okay. Now, here it is del f by del x, and it is also del x by del r, because now x is a function of two unknowns r and s. So, instead of complete derivative, now you will be having partial derivative. So, it is del x by del r. Again here it will be del f by del y, and it will be del y by del r. It is del f by del z, and here it is del z by del r. So, what will be del w by del r? It will be equal to del f by del x into del x by del r. So, one branch is over, plus del f by del y into del y by del r, plus del f by del z into del z by del r. So, this will be basically del w by del r. Now, similarly, if you want to compute del w by del s, so that will be, it is del f by del x, it is del x by del s, it is del f by del y, it is del y by del s, here it is del f by del z, and it is del z by del s. So, del w by del s similarly will be del f by del x into del x by del s plus del f by del y into del y by del s plus del f by del z into del z by del s. So, that is how we can compute del w by del r or del w by del s in such type of problems. Okay. Now we will try to solve some problems based on this first. Now, let us suppose w is 2y into e raised to power x minus ln z, where x is function of t, that is ln t square plus 1, and y is also a function of t, which is tan inverse t, and z is again a function of t, it is e raised to power t, and we want to compute dw by dt at t equal to 1. Okay. This we want to find out in the first problem. Okay. How can we compute this? Now, at t equal to 1, x is ln 2, y is tan inverse 1, which is pi by 4, and z is e raised to power 1, that is e. Okay. Now, dw by dt, first you write dw by dt, then we will find at t equal to 1, it is del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. This is simply by chain rule. Okay. Now, del w by del x is 2y e raised to power x, and dx by dt from here is, now dx by dt is, you suppose this as some function. So, ln this is 1 upon t square plus 1 into derivative of this, which is 2t, plus del w by del y from here is 2 e raised to power x, okay, and then it is dy by dt. Dy by dt is 1 upon 1 plus t square, again plus del w by del z, partial derivative of this w with respect to z. No z is here, so it is 0, and from here it is minus 1 by z into derivative of this with respect to t, which is e raised to power t. Now, you want to compute dw by dt at t equal to 1. So, x is ln 2, y is pi by 4, and z is e at t equal to 1. You simply substitute it here. So, 2 into pi by 4 into e raised to power x is 2 from here, t is 1. So, it is 1 plus 1 is 2, and it is 2 into 1 is 2, plus again e raised to power x is 2. So, it is 2 into 2, it is 1 upon 1 plus 1, that is 1 upon 2, plus, so it is minus sign. So, minus will come, and z is e. So, it is 1 by e into, and e raised to power t is e, because t is 1. So, what we will obtain from here? This will cancel out, this will cancel out, this will cancel out, and this cancel out. So, we will obtain pi from here, and we will obtain plus 2 from here, minus 1, that is pi plus 1. So, pi plus 1 will be the final answer. Okay. Now, similarly, we can try for the second problem. Now, w is, for second problem, w is x plus y upon z, x is cos square t, okay, y is sin square t, and z is 1 by t, okay, and at t equal to 3. Now, at t equal to 3, x is cos square 3, y is sin square 3, and z is 1 by 3. Okay. Now, you first compute dw by dt, then we will compute dw by dt at t equal to 3. Now, dw by dt by again by the chain rule, it is del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. So, this will be del w by del x from here is 1 by z, okay, and into dx by dt, which is 2 cos t into minus sin t, plus del w by del y is again 1 by z into del dy by dt from here is 2 sin t into cos t, plus del w by del z is x plus y upon minus z square, because 1 by derivative 1 by t is minus 1 by t square, okay, into dz by dt, dz by dt is minus 1 by t square. Now, this term and this term cancels out, and it will be x plus y upon z square t square. Now, z into t is 1. So, it is equal to x plus y, and at t equal to 3, it is cos square 3 plus sin square 3. okay, because it is x plus y and x is cos square 3 and y is sin square 3. So, it is 1. So, the answer is 1. Okay. So, that is how we can simply apply chain rule to find out derivative with respect to t or some other variables. So, this I have already discussed. Now, come to some more problems based on this. So, we will compute, say we will take first problem, z is 4 e raised to power x and ln y, and x is ln r cos theta and y is r sin theta, and the point is 2 comma pi by 4. Okay. So, in the first problem we have to find out del w del z by del r or del z by del theta at 2 comma pi by 4. So, how can we compute? Now, here z is a function of x and y, and x and y are again functions of two variables r and theta. Okay. So, how can we find del z by del r suppose? So, either we can make use of tree diagram or we can write directly. It is a z is a function of x and y. So, it is del z by del x into del x by del r plus del z by del y into del y by del r. And similarly, if you want to find out del z by del theta, so it is del z by del x into del x by del theta plus del z by del y into del y by del theta. Okay. Similarly, you can write this by the chain rule. So, what is del z by del x? It is 4 e raised to power x into ln y into del x by del r is 1 by r plus del z by del y, it is 4 e raised to power x upon y into del y by del r is sin theta. So, this is the expression. Now, this is del z by del x, it is 4 e raised to power x ln y, del x by del theta, from here it is 1 by cos theta and it is minus sin theta plus del z by del y is 4 e raised to power x upon y and del y by del theta is r cos theta. So, now you can easily compute these values at r equal to 2 and theta equal to pi by 4, because at r equal to 2 and theta equal to pi by 4, x is ln 2 into 1 by under root 2, which is ln under root 2, that is 1 by 2 log 2. Okay. And y is equal to r sin theta, r is 2, theta is this. So, it is 2 into 1 by under root 2, which is under root 2. So, you can simply substitute x equal to this, y equal to this, r equal to this and theta equal to this in this and this expression. So, we can easily find out del z by del r or del z by del theta in the first problem. Similarly, we can solve second and third problem also. Let us try the last problem, del z by del p and del z by del q. Okay. Now, here in the last problem what we are having? We are having z is equals to x cube plus y cube plus it is okay minus it is 3x square y plus 6xy square. Now, x is equal to, it is a function of u and v, which is u square plus v square, and y is again a function of u and v, which is u square minus v square. Now, u and v are again function of two variables p and q, which are given by u is p minus q and it is p square plus q square. p square plus pq, sorry. So, when you substitute x as u square plus v square and y as u square minus v square and again u as p minus q and v as p square plus pq. So, z will be a function of p and q. So, we have to compute del z by del p and del z by del q in this problem at p equal to 1 and q equal to 0. So, how can you find this? How can we first write chain rule for this expression? So, let us see. Here z is a function of x and y, okay. We will first try to write down the chain rule for del z by del p and similarly we can compute del z by del q, okay. Now, z is a function of x and y, x is a function of u and v. Here also it is a function of u and v and all other functions of p, okay. And we want to compute del z by del p, we want to compute del z by del p, the first expression del z by del p, okay. So, this is basically del f by del x, this is del x by del u, this is del u by del p, this is del x by del v, this is del v by del p, this is del f by del y, this is del y by del u, this is del u by del p, this is del y by del v and this is del v by del p. Now, how can we write del z by del p? Now, del z by del p will be given as, now first you come to this point and then you come to this point, okay. So, for this point this into this plus this into this and whatever we are obtaining at this point multiply this with this. So, then the first branch will be over and similarly for the second branch and add them we will get del z by del p. So, what will be del z by del p? It will be del f by del x into whatever we are obtaining from here, this is this into this plus this into this, that is del x by del u into del u by del p plus del x by del v into del v by del p, this first branch. And from a second branch it is del f by del y into del x del y, del y by del u into del u by del p plus del y by del v into del v by del p. So, this is by the second branch. So, this is the expression for del z by del p. You can see from here also that f is a function of x and y and x and y are the functions of u and v which are in turn are the functions of p and q. So, del z by del x into del x by del u with p and del x by del v with del v by del p, because x and y both are the functions of u and v both are the functions of p if you are talking about del z by del p. Similarly, for del z by del y the same expression here with y. So, it is easy to remember if we draw a chain if we draw a tree diagram for the same. By the tree diagram we can easily write down such expressions, okay. Now, similarly we can compute del z by del q, it is del f by del x into del x by del u into del u by del q plus del x by del v into del v by del q plus del f by del y into del y by del u into del u by del q plus del y by del v into del v by del q. Similarly, simply replace p by q, we will get back to this expression. Now, you can find out all these values from these expressions, substitute it over here and at P equal to 1, Q equal to 0, first U is 1 and V is 1. When U is 1, Q is 1, X is 2 and Y is 0. So, you simply substitute all these points in this expression after solving this. So, we can compute del Z by del P or del Z by del Q at P equal to 1 and Q equal to 0. So, this is how we can solve some problems based on chain rule. So, thank you very much.